Today I'm going to teach you about touching angle pairs. Touching angle pairs means literally they're in the same area, in the same neighborhood, and they're actually touching each other, meaning that the sides or the vertices, the point to the angle is touching each other. So let's begin with the most basic example. And the most basic example are just ones that are called adjacent angles. This, by the way, is a symbol for angles. The definition is that they share a common side and vertex, but don't overlap. So really, that means that they're just kind of joined on the side. So if I wanted to show you an example, I could just draw any two angles as long as their vertex, this point here, is touching each other and I have their rays going off in whatever direction. So here, angle A and angle B are adjacent angles because they share a common side and a common vertex. Complementary angles aren't just very polite complementing angles. By definition, they are two angles who add to 90 degrees. So when I think about it, I think about that right angle. I think about that little thing we did in the corner, like when we did specifically Pythagorean theorem. And it can be of any size in the middle. So again, they have to show, that was a very not straight line. Let's see if I can do better. Even with a ruler, sometimes Ms. Robeck isn't perfect. So right here, they have to show me that that's 90 degrees and that I have angle A and angle B. So even though these are still adjacent, this is a more specific relationship. It's like saying the difference between a quadrilateral, which is anything with four sides, versus having a rhombus or a rectangle. I want to be as specific as possible when I'm naming angles. The next one we're going to talk about is supplementary angles. And supplementary angles are two angles who add to 180. So I think about these as straight line pairs. Some people call them that, linear pairs. So in other words, I have a straight line because that's exactly 180 degrees and there's some ray coming from it. Again, these obviously don't have to be in this orientation. You could flip this around, but notice again, they're touching. And even though again, they are adjacent, this is a very specific thing that they are equaling up to 180. And the last one, and one we'll use a lot, is something called vertical angles. And vertical angles are pairs of congruent, that means equal in size, opposite angles made by intersecting lines. So I think about that I have two lines that form an X. If I need to have vertical angles, I better see an X somewhere on my paper. And that here, A and B are vertical angles. I also could get the other two sides. These are also vertical angles from each other. So these two are congruent or the same size. These two are congruent. In this case, they are not adjacent angles because they share a vertex, but not a side. So how do I use all this vocabulary to do some of my math problems? Well, let's say I gave you an example where I want to know what is the complement of a 37-degree angle. Well, here comes in my vocabulary. What does complement mean? Complement means it must add to what? Oh yeah, 90. So if I want these two to add to 90, what angle do I need? Well, I need a 53-degree angle. And I could do the same thing with any of the other vocabulary. If it's supplementary, I'd have to add to 180. If it's vertical, it would be the exact same measure. So hopefully that gives you an idea of how to do that type of problem. What about if they give me some algebra ones? So again, here's some more notation. Watch how I'm reading this. This says if the measure of angle 1, so in other words, I want to find the size of angle 1, but all I know is this algebraic expression. The measure of angle 1 is 6x plus 14. And then they tell me something about the size of angle 2. The measure of angle 2 is 2x minus 2. That's still not enough information for me to solve, so they better tell me something else. And they are supplementary angles. Great, now I can do something. So the first thing they're going to ask me to do is to find x. Well, since they're supplementary, again, what's that mean in my vocabulary? They add to 180 degrees. So that means that if I add these expressions, in other words, if I add 6x plus 14, and I add the other expression plus 2x take away 2, they have to all add up to 180. Well, what do I do now? Look, these are all on the same side, so I just collect like terms. So I know that 6x and plus 2x, that would be a total of 8x's. Positive 14 minus 2 plus 12. Oh, I hope this is an easy problem for you now. We subtract 12 to both sides. So 8x is equal to 168. You divide by 8, and you're welcome to use a calculator if you need to, but you should figure out that x is 21. That's great. That's what we asked me to do here, but what if I want to know a little bit more? What if instead it asks me to find the measure of angle 1? Oh, well, now I know what x is, so I will just substitute that into my expression up here. 6 times 21 plus 14. Ooh, 6 times 21, that's a big number. That's 126 plus 14. So I found out that this is 140 degrees. What about if they told me to find the measure of angle 2? Well, now I need to take the 21 and substitute it in for x. 2 times 21 minus 2. 2 times 21 is 42. Take away 2 is 40. My last check is, do they add to 180? Yes. That means I must have done a fantabulous job doing this math. I'm going to show you one more, and I'm just going to start it just to give you an idea of what if they said instead, if the measure of angle 3 is 9x minus 2, and the measure of angle 4 is 8x plus 7. Again, I need one more fact because I don't know their relationship. And they are vertical angles. Can I now find x? Well, what's the relationship with vertical angles? I could look at a picture. So if I'm thinking about the picture, again, it's like an x always. I have 9x minus 2, 8x plus 7, but their special relationship is that they're equal. So the math problem I'm going to have to do is going to look like this. And again, hopefully you know how to solve that. You can subtract 8x's. X minus 2 equals 7. And if I add 2, as I'm running out of space, you can find x equals 9. I hope if you've wanted to continue this problem, you could plug in 9 and check that they're both equal. I hope this helps you understand our touching angle pairs.